It could seem impossible, but the time we are living is slowed down. By what? Roughly the gravity of Earth. For Newton's gravitational law, each mass plus 2 creates a gravitational field that in modern physics modifies spacetime as a bowling ball does with a trampoline. A generic gravitational field H is mathematically expressed as the product between the gravitational constant g and the mass m of a planet divided by its radius r squared. In the case of Earth, we have an acceleration about 9.8 meters per second squared. MacLeod had to wait for Einstein's theory of special relativity in 1905 to understand that terrestrial time is dilated. In fact, demonstrated the principle of equivalence, which states that inertial mass is equal to the gravitational one. Should the principle be violated, each body will be attracted by Earth in a different way, but it has been established that the gravitational acceleration is always the same. This principle in theory is very simple and has led to many serious consequences, sometimes determined thanks to thought experiments. Let me assume, for example, a long rocket with two astronauts, John in Moscow and Carl in the engine area. The distance between them is covered by light in 0.5 seconds. We have to use light because its speed is independent from the two astronauts' motion according to the special relativity. Now, according to the principle of equivalence, we are able to determine if we are moving with a constant acceleration or we are standing still under the effect of a gravitational field. For the experiment, we know that the rocket has an acceleration equal to 9.8 meters per second squared as a terrestrial gravitational field. The two astronauts decide to send each other a beam of light, checking the time on their watches. When Carl sends the signal, the rocket moves forward and in 0.5 seconds, supposing a uniform accelerated motion, it travels about 1.22 meters. So the beam has to travel 1.22 meters more before it arrives to John. Because light has a constant speed, the time is bound to increase according to the laws of uniform motion. Now, in virtue of the principle of equivalence, we can consider this rocket motionless and vertical on the Earth. For Carl, time passes slower than John as it happens in space because the delay of time is given by this formula, where E is the Nepper's number, based on the natural logarithm. Gh is the gravity acceleration in function of height, h is the vertical date of the considered object, and c is the speed of light. If you wonder a second on planet X is equal to 2 seconds on Earth, consider they have the same radius and that the object is far 30 kilometers. This planet should have a density of about 1.17 quadrillions kg per cubic meter, while Earth has only a density of 5,510 kg per cubic meter. The only bodies capable of having such densities are black holes, where the space-time curvature caused by the enormous gravitational field could potentially stop the time. So, if we will be able to enter a black hole, stay for milliseconds, and then come out safe and sound, we will quite surely find ourselves in a future too much distant to be imagined and scripted.